Now let us discuss next example. Find the equation of the plane in vector form passing through the points 1, 0, 1, in bracket 1, -1, 1, in bracket 4, -3, 2. In a plane, coordinates of 3 points are known to us, and we have to find equation of plane passing through these points. Suppose these are the points A, B, C. In previous example, position vectors of 3 points in plane were given, and here coordinates of 3 points are given. So solution for this is similar to previous example. Only additional thing is that here coordinates of point are given. From that we have to find their position vectors. So we shall consider given points A, B, C. A 1, 0, 1. B 1, -1, 1. C 4, -3, 2. Now we have to find equation of plane. If we know position vector of one point in a plane and vector perpendicular normal to the plane, then we can find equation of plane in vector form. From coordinates of points we shall find position vectors, and usually position vectors, they are denoted by small letters. Position vector of a point, it is a vector directed from origin towards that point. Position vector of point A, OA bar, and it is usually denoted as A bar. Coordinates of point, they become coefficients of unit vectors I, J, K. X coordinate becomes coefficient of I, Y coordinate becomes coefficient of J, Z coordinate becomes coefficient of K. 1I plus 0Z plus 1K. When coefficient is 1, we need not write that term. 0Z, that is 0. So we need not write that term. We get I plus K. B bar 1I minus 1J plus 1K. So coefficient 1 not necessary to write. I minus J plus K. C bar 4I minus 3J plus 2. So we know position vectors of 3 points in a plane. What we require? Vector perpendicular to the plane, which is normal to the plane. Join AB bar, join AC. As points A and B are in the plane, AB bar also lies in the same plane. A and C lie in the plane, so AC bar also lies in that plane. Cross product of two vectors is a vector quantity, and it is perpendicular to plane of both those vectors. So AB bar cross AC bar, it is perpendicular to plane of AB bar and AC bar. AB bar cross AC bar perpendicular to the required plane means it is normal to the plane. Means we have to find cross product AB bar cross AC bar. Before that we have to find AB bar and AC bar. Here we know position vectors of points. We don't know vectors AB bar or AC bar. AB bar vector directed from point A towards point B. A initial point, B terminal point. And vector in space can be expressed as position vector of terminal point minus position vector of initial point. I minus I cancel. Minus J. K minus K also gets cancelled. AC bar, A initial point, C terminal point. C bar minus A bar. I 4I minus I 3I minus 3J plus K. After that, we have to find their cross product, because AB bar cross AC bar, it is perpendicular to the required plane. It is normal to the required plane. AB bar and AC bar, they are in terms of unit vectors. So use determinant here. And determinant in first row, unit vectors ijk. In second row, coefficients of ijk for first vector AB bar 0, minus 1, 0. In AB bar, terms of I and K are absent, so their coefficients 0. Coefficient of J negative, minus 1. In third row of determinant, we have to write coefficients of ijk for second vector AC bar. So 3 minus 3, 1. Evaluate I into minus 1 minus 0 minus J into bracket 0 minus 3 plus K into bracket 0 minus minus plus 3. Minus I plus 3J plus 3K. Now AB bar cross AC bar, as it is perpendicular to plane, we shall denote it by N bar, normal. Equation of plane, R bar dot N bar equal to A bar dot N bar. R bar dot N bar, normal vector, minus I plus 3J plus 3K equal to dot product of two vectors here, A bar I plus K dot in another bracket minus I plus 3J plus 3. Find sum of product of coefficients of ijk. 1 into minus 1. Minus 1. Term of j absent here. 0 into 3. 0. 1 into 3. 3. R bar dot in bracket minus I plus 3j plus 3k equal to 2. This is equation of plane in vector form. In the example, it is not mentioned in which form we have to find equation of plane. So we shall find equation of plane in vector form as well as Cartesian form. For getting equation of same plane in Cartesian form, we shall take point R whose coordinates x, y, z. Then position vector of point R bar, xi plus yj plus zk. Dot product of two vectors on LHS. After simplification, we get minus x plus 3y plus 3z equal to 2. This is equation of same plane in Cartesian form. if coordinates of 3 points in a plane are known to us and we have to find equation of plane, then from coordinates of point we can find position vectors. After that, we want vector perpendicular normal to the plane. Then before that, we have to find two vectors in space, AB bar and AC bar. AB bar and AC bar we can find. After that, find their cross product. It is a vector which is normal to the plane. Next example. Find the equation of plane passing through intersection of the planes. Three x plus 2y minus z plus 1 equal to 0 and x plus y plus z minus 2 equal to 0 and the point 2, 2, 1. Now here we have to find equation of plane which is passing through intersection of given two planes and one point. In case of lines, when lines intersect, they intersect in one point. So intersection of two lines is a point only. When planes intersect, their intersection is a line. And here we have to find equation of another plane passing through that intersection, passing through that line. Through one line, infinite planes can pass. But one more condition is given, that plane is passing through given point. In which form equation of plane we have to find? It is not mentioned in the example. But given equations of planes, equations of two planes are given and both the planes, they are in Cartesian form. So in this example, it is sufficient to find equation of plane passing through intersection of these two planes in Cartesian form only. So these are the equations of two planes. On right hand side, 0 is there. So equation of plane through intersection. In one bracket, 3x plus 2y minus z plus 1 plus lambda into another bracket, x plus y plus z minus 2 equal to 0. If equations of two planes in Cartesian form are a1x plus b1y plus c1z plus d1 equal to 0. Another plane, a2x plus b2y plus c2z plus d2 equal to 0. Then equation of plane passing through intersection of these two planes, it is given by, in one bracket, a1x plus b1y plus c1z plus d1 plus lambda into bracket a2x plus b2y plus c2z plus d2 is equal to 0. In same form, we have written equation of plane. instead of writing scalar quantity lambda outside second bracket, we may write it outside first bracket also. It does not change final solution. Final solution remains same. Now this equation represents equation of plane passing through intersection of these two planes. And there are infinite planes passing through intersection. So for every value of lambda, we get one plane. As lambda can have infinite real values, we get infinite planes passing through intersection of two planes. But here one condition is given. For convenience, here we shall denote this as equation 1. One condition is given, that required plane, it passes through given point. Means that point lies on plane. As point lies on plane, its coordinates satisfy equation of plane. So put x equal to 2, y equal to 2, z equal to 1 in equation of plane. And when we put these values in this equation, only one unknown remains, lambda. So we get value of unknown lambda. And when we put value of lambda in this equation, we get only one plane which is passing through intersection of two planes and passing through given point. So put these values. 3 2s are 6, 2 2s are 4, minus 1 plus 1 plus lambda into bracket 2 plus 2 plus 1 minus 2 is equal to 0. In first bracket, minus 1 plus 1 cancel. In second bracket, 2 minus 2 cancel. 10 lambda. So, in first term, 10 is there. Plus 3 lambda equal to 0. Find value of lambda. 3 lambda minus 10. It means that lambda is minus 10 by 3. Now after getting value of lambda, put that value in equation 1. As we have got only one value of lambda, we shall get unique plane passing through intersection of two given planes and passing through given point. Put this value here. First bracket as it is. 3x plus 2y minus z plus 1. Lambda is negative. Minus 10 by 3 into bracket. X plus y plus z minus 2 equal to 0. Now we have to simplify this equation further. For that, we have to eliminate 3 from the denominator. And to eliminate 3 from the denominator, multiply equation by 3. Now multiply each term here. 3 3s are 9, 3 2s are 6, minus 3z plus 3. Open the bracket, multiply by minus 10. Minus 10x minus 10y minus 10z plus 20 is equal to 0. Rearrange the terms. First collect terms containing x. 9x minus 10x minus x. 6y minus 10y minus 4y minus 3z minus 10z minus 13z. Collect the numbers. 20 plus 3, 23 equal to 0. For convenience, we can multiply equation by minus 1. X plus 4y plus 13z equal to 23. Now this is equation of plane which is passing through intersection of two planes and one more point. This equation, it is in Cartesian form. In the example, we have to find equation of plane. It is not mentioned whether to find in Cartesian form or vector form. But given equations of two planes, they are in Cartesian form. So it is sufficient here to find equation of plane in Cartesian form.
Welcome to Sanjeevani Education Group. Sanjeevani Education Group is a IIT NEET coaching hub which is renowned for producing the rankers in different competitive exams from national level 11th and 12th JEE NEET, Standard 10th NTSC MTSC, 6th and 9th Dr. Homi Bhabha Bal Vaidyanik exam, 5th and 8th scholarship exam, 7th Olympiads along with IIT NEET Foundation for all classes. We have experienced faculty who focus on the academic development of students. So dear parents, hurry up. For admission, visit Sanjeevani Education Group, plot number 13, Aditya Nagar, Gadkhera, Aurangabad, or call 95112 70135 or 95112 66680.